The first type of factoring that we're going to start with is finding the greatest common factor, or the GCF. So the GCF, or greatest common factor, is looking at a polynomial with multiple terms. So the terms are separated by the plus and the minus, right? So if I look at this one has two terms because there's two things separated by a plus. This one has two terms as well because it's separated by a minus. This one's actually a little confusing looking because there's pluses and minuses in here, but this is all still one term because it's all multiplied together. So that's one term, and this is one term separated by a plus because that's all multiplied together. So this is also still just two terms. This one's two terms. This one's two terms. A lot of the ones we dealt with this morning were like 4 and 5 terms, right? Because there was lots of pluses and minuses. Down here we have 4 terms, 1, 2, 3, 4, all separated by a plus or a minus, okay? So when you are looking for greatest common factor, you want to look for the common factor in all of the terms. So something that is common to every single term in that polynomial. So this one only has 2 terms. So let's look at the numbers first, 18 and 27. What number are both of those divisible by? 3 is definitely one of them. Is there a bigger number? Because we want the greatest common factor. They're also both divisible by 9, right? So the GCF for this polynomial will start, the GCF is 9, okay? That's not it, but it at least has a 9 in it because that's a greatest common factor with the numbers. And then we also have to look at the letters. So this one has 3 x's being multiplied together. This one has 2 x's multiplied together. So how many, what's the greatest amount they have in common? X squared or 2 x's, right? Because that's x times x, right? So they have x squared in common. That's the greatest amount they have in common. So your GCF here is 9x squared. That's your greatest common factor because it's the greatest number that is a factor of both terms, okay? Now, when we use the GCF to factor or undo multiplication. So then once you find the GCF, you write it in the front of the parentheses. So you write the GCF down first. You're going to put that in front of the parentheses. And now we're going to factor that out or divide that by each term. We're undoing multiplication. So if I divide 18 by 9, what do I have left? 2. And if I divide x cubed by x squared, i.e. take out an x squared, how many x's do I have left? Just 1, right? X to the 1 power. But then I have the plus sign here that separates the 2 terms. So I need to put that in there. And now I'm going to look at the second term and see what do I have left when I divide out or take out 9x squared. So what is 27 divided by 9? 3, right? And what do I have left if I divide out by x squared or I take out an x squared? Do I have any x's left? No, so that's just 3 in that term. And then I close my parentheses, and that ends my factoring process, right? I have divided out 9x squared. Now, if you were to undo this process and do what we just practiced a second ago, you multiply 9x squared times 2x and 9x squared times 3, you distribute, you're going to end up right back where we started, right? We're undoing the multiplication process when we're factoring, right? We're undoing the multiplication process. Now, there's different types of factoring because there's different types of multiplication that we do, right? So that's why there's going to be different types of factoring. But that's all that you're doing here with the GCF is you're looking for the greatest common factor in every term and pulling it out in front, undoing that multiplication by dividing. Any questions on number 1? All right, now let's look at number 2. We're going to look for the greatest common factor that's in both terms here. So let's look at the numbers first, 12 and 20. What is the greatest factor they have in common? 4, I think, right, is the biggest one. You got 6, but that doesn't divide 20. You got 2, that's not big enough, right? We want the greatest. So our GCF is going to have a 4 in it. And then we look at our letters. The A's, there's an A squared and an A cubed. What's the most that they have in common? A squared, right? This one has 2, this one has 3, so the most they have in common is 2, right? A squared. This one has a b squared, and this one has a b, so what's the most they have in common? Just b, just 1b. Because this one has 2, this one only has 1. And so that's your GCF, 4a squared b. That's your greatest common factor. So we write that in front of the parentheses when we're factoring, and we're going to figure out what's left in each term here. So when I look at this first term here, 12 divided by 4 is 3, so I will have a 3 left when I pull out 4 or factor out or divide out 4. I took out an a squared, so should I have any a's left in that first term? No. I took out a b, so how many b's should I have left in that first term?
1b.
Just 1b. And when I mean 1, I mean the power, right? So if you want to write that in the power, you can. Then you have your minus that separates the two terms. When I divide 20 by 4, I'm left with 5. I took out an a squared, so should I have any a's left in this term?
1a.
Just 1, because there was 3. And I took out a b. Should I have any b's left? No. So when I factor out that greatest common factor, that's what that looks like. Now, I don't usually write my answer with the 1s in it because we just don't see it that way. But if you like to have it in there, that's totally fine. But that's probably what it will look like. So this is your GCF in the front. This is your greatest common factor, and you factored that out or divided that out. If you multiply this, if you distribute, you're going to end up right back where you started if you did it correctly, right? That's the nice thing about factoring is you can always check your answers. Multiply it out, and if you get what you started with, then you did it correctly because you're undoing the multiplication process. All right, number 3 looks a little weird, but it's going to help us with what we're going to do next. So that's why we're talking about this one. So this one here, as I already talked about, it looks like there might be a lot of terms here, but there's actually only 2 terms. This is a term, and this is a term, separated by the plus sign in the middle, because the 2x and the x minus 7 are being multiplied together. So that's all one term because it's all multiplication. The 3 and the x minus 7 are all being multiplied together, so that's one term. So there's really only 2 terms here. 2 and 3, do those numbers have any common factors? Do 2 and 3 have any common factors? Just 1, right? We can technically always factor out a GCF of 1, but most of the time we don't. There's only one case where we will do that, okay? They don't have an x in common with this part right here. This one has an x, but the 3 doesn't have an x with it. But what do these have in common? What factor do these have in common? X minus 7, that's its own factor, right? Factors are things that are being multiplied together. So this guy right here has 3 factors, 2, x, and x minus 7. Those are all being multiplied together. So those are the 3 factors, right? The factors of 6 are 2 and 3, because 2 times 3 is 6, right? So this guy has 2 factors, 3 and x minus 7. So their greatest common factor here is x minus 7, because that is a factor of both. So that's going to be your GCF in the front. And we're going to write it in the parentheses so that we say that whole thing, x minus 7, is the GCF. So now when I go to, so the GCF goes in the front. When I go to write what's left in each term, I need to look at this first term. What's left in that term when I pull out x minus 7? Just 2x. I've got a plus sign in between, separating the 2 terms. And then when I look at this guy here, when I have the second term, when I pull out x minus 7, what am I left with?
3.
Just 3. So the GCF here was a little weird because it was x minus 7, but this is going to come into play a lot here in a second, okay? And so our GCF was x minus 7. We pull that out. We factored. We had 2x left in the first term and a 3 left in the second term. So we have now factored that problem. If you were to multiply it out, you'd have to only half multiply it to get here. If you wanted to multiply it all the way out, then you could compare them to see if they were the same. Any questions? All right, try 4 and 5 on your own if you haven't already. All right, so I'm going to go over number 4 here. So for number 4, you're looking for a GCF. So you're looking for the greatest common factor. If you look at 35 and 21, their greatest common factor is 7, so that will be part of our GCF. We have an x squared here, and we have an x over here. So the only common x they have is just a single x. This one has y squared, and this one has y cubed. So what they have in common is a y squared. So this is your GCF right here, your greatest common factor. Okay, now why did we find that? Well, because we're going to factor that out of each term. So you have 2 terms here. We're going to factor 7x y squared out of each one. So we're going to divide out or pull out 7x y squared. So 35 divided by 7 is 5. If we pull out an x out of x squared, you should have an x left. And we pulled out a y squared, and there was a y squared, so there should be no y's left. Then you have the plus separating the two terms here. And now we're going to look at what's left in the second term. So if I divide 21 by 7, I should have a 3 left. When you're dividing or pulling stuff out, you're dividing. I pull out a y squared. There was a y cubed there, so I should have a y left. And I pulled out an x, but there's only an x left, right? I pulled out an x and a y squared. So the x is gone, there's no x, and I pulled out a y squared, so there's just a y left. And so that is your factoring. You use the GCF, you put it in the front there, and if you were to undo this and do the multiplication, you would end up where you started. So for number 5, to find our GCF, our greatest common factor, we'll look at first 25 and 15. Their common factor is 5. This one has an a cubed. This one has an a to the 5th. So these guys actually have a cubed in common. That's the biggest amount of a's they have in common. This one has a b and this one has a b cubed. So the only thing they have in common is b. So that's our GCF, our greatest common factor. Now to factor, we're going to pull that out of each term. We're going to see what's left with each term here as we divide that out. So 25 divided by 5 will be 5. We pulled out an a cubed. There was an a cubed, so there's no a's left. We pulled out a b. There was a b, so there's no b's left. So that one just has a 5 left. There's a minus sign in between the two terms. 15 divided by 5 is 3. We pulled out an a cubed. There was an a to the 5th, so there should be an a squared left. We pulled out a b, and there was a b cubed, so there should be a b squared left. Any questions on that one? All right. The part that I think most people tend to struggle the most with is factoring by grouping, okay? This is not that hard if you understand the GCF, but if you have a hard time with the GCF, this might be a little tricky, okay? So we're going to talk about factoring by grouping here. So factoring by grouping is usually used when we have an even number of terms. But honestly, so like 2, 4, 6, 8, 10, anytime you have 2, 4, 6, 8, 10. But usually we use factoring by grouping when there's 4 terms, okay? So usually 4. If there are 4 terms, then it's probably a factor by grouping problem, okay? You should always look for a GCF first when you're factoring at all, period. You should look to see if every term has a factor in common before doing any factoring. That should always be your first step. That's why we started with the GCF, okay? So if we look here, there are 4 terms here. X cubed, 4x squared, 3x, and 12. They're all separated by plus signs, so those are 4 terms, okay? This is probably going to be a grouping problem, but we should probably check for a GCF first because we should always do that. So is there a number that all 4 terms have in common? Is there a number that all 4 terms have in common? Besides 1, right? This one has a 1, 4, 3, and 12. Sure, 4 and 3 are both factors of 12. That's why this is going to be a grouping problem. But they're not all, it's not common to all 4 terms, right? Do all 4 terms have an x in them? Not the last one. The last one doesn't have an x in it, right? So there is no GCF here. There is no greatest common factor besides 1 because there's not a common factor for all 4 terms, okay? So check for that first. Then, if we still have 4 terms and no greatest common factor, we're going to use factoring by grouping. When you do factoring by grouping, you're going to think about it in pairs. So you're going to look at the first 2 terms together and the second 2 terms together. So I like to draw myself a little invisible dotted line kind of down the middle, just a temporary dotted line down the middle to separate the first pair and the second pair. And now, even though we don't have a GCF for the whole thing, in each of these pairs, there's a GCF. So if I look at this pair here, they don't have a common factor for the numbers. 4 and 1 don't have a common factor, but what about the x's? Do they have a greatest common factor, those 2 terms? What do they have in common? X squared, right? So you're going to factor out the GCF just for those two terms. So you're going to put an X squared in the front like we usually do with the GCF. And then in parentheses, you're going to write what's left in each of these terms. So if I factor out my GCF of X squared, what will be left in this first term here, X cubed? Just an X, right? Then we have a plus sign separating those two terms. And what will be left with the second term here if I factored out an X squared? 4. There's no X's left. We pulled that out. We have an X plus 4. And we're going to do the same thing on the other side. We're going to look for a greatest common factor with these two pairs. So on this side, what two numbers are those both divisible by? 3. There's no X's in common, right? But they do have a number. When you pull out that number, you're going to put the sign in front of that number. So if it's a positive 3, you're going to put a positive there. If it's a negative 3, you're going to put a negative there. So since this is a positive 3, we're going to put a positive there. Because we still have this plus sign separating these two terms right here, right? But if that's a negative number, then it will just become a negative. And then we're going to write down what's left when we factor out that greatest common factor. So what's left in this first term here, 3x, when I pull out a 3? X or 1x, you can write 1x if you like that, that's fine. Then we have a plus sign separating the two terms. And what's left for the 12 when I divide by 3? 4. And if you've done factoring by grouping correctly, you should see a matching factor on both sides. So do we have a matching factor on both sides here? Yes, x plus 4. And this is why I did this example above here. See how this looks just like this guy up here? You still have two terms here. These two are two factors multiplied together. These are two factors multiplied together, and it's all separated by a plus sign, okay? So I have two terms here now. Instead of 4, I have two terms, one term, two terms, separated by a plus. And so now I'm going to look for the GCF of these two terms. So what do these two have in common? X plus 4. So we're going to pull that x plus 4 out. I'm going to erase my wall because we're not really separated anymore. So I'm going to pull my x plus 4 out. That's the greatest common factor. And then in parentheses, I'm going to write what I have left in this first term here. When I pull out x plus 4, what do I have in this first term if I take out that x plus 4? Just x squared, right? Then they're separated by this plus sign in the middle, right? So this is one term, this is one term, they're multiplied together. So separated by a plus sign in the middle. And then what do I have on this side of my wall when I pull out x plus 4? Plus 3, positive 3. And if you wanted to, you could check your answer to see if this is correct, because we know how to multiply these together, right? We could FOIL this out, we could distribute this out, and if you do it, you would end up here if you've done your factoring correctly, right? So what we're doing is we're undoing that multiplication process with factoring. So this is my answer. If you wanted to check yourself, you could multiply it back out and see if you end up back where we started. Any questions on the grouping? All right, let's do number 7. So there are 4 terms here. You want to look for a greatest common factor of all 4 first. Do all 4 terms have a common number? Do all 4 terms have a common number? No, this one has a 1 with it, right? So there's definitely nothing in common. Do they all have an x with them? Nope, not the last one. So there's no GCF for the whole thing, right? So instead, because there's 4 terms, this kind of screams factor by grouping. So we're going to put a dotted line down the middle, and we're going to do the GCF of this side and the GCF of this side. So if I look on the left-hand side here, what is a GCF, greatest common factor, I can pull out of those 2 terms? X squared. Then in parentheses, we write what's left out of these 2 terms here. So x cubed, when I pull out an x squared, I'll be left with an x. There's a plus sign separating these 2 terms. And then 5x squared, when I pull out an x squared, I'll just be left with a 5. Now this side over here, what do I have in common? What's my GCF?
Negative 2.
-2. And here's a trick with this stuff. Even if they both don't have a negative, if this first one has a negative with it, you want to go ahead and factor out a negative with your GCF. Technically, you could always factor out a negative with your GCF, but if this first number here has a negative with it, you always want to make that a part of your GCF. So if there's a negative right here, you want to bring a negative down, but you're going to have to pull that out of each one, divide each number by a negative. So we also said they both have a common 2, so our GCF here is -2. What happens here if I divide this by -2? What am I left with? Just a positive x. And then here's the tricky one. What happens when I divide -10 by -2?
Positive 5.
Positive 5, right? We factored out a -2. So this should be a positive 5 because -10 divided by -2 will be a positive 5, which is good because now we have 2 matching factors, right? And that's what we want if we've done it by correctly. So we'll pull that x plus 5 out. That's the matching factor here in these two terms. And then we write down what's left when we pull that out. So here we have left when I pull out the x plus 5. What do we have left? X squared. On the right-hand side, when I pull out the x plus 5, we have a -2 left. So x squared minus 2. If you wanted to check your answer, you could multiply that out by foiling or distributing or box method, and you should end up right back where we started if you wanted to see if you got it correct. Any questions on number 7? All right, I'd like you to try the last one on your own. All right, so this one, there is no common factor to all 4 terms. At the beginning, you should always check for that first. Since there's 4 terms, it's probably a grouping problem. You're going to draw the line down the middle. You can factor out a 3x squared here. Both of these have a common factor of 3 and an x squared, so that's your GCF this time. That'll leave you with x plus 2, because when you take out 3x squared, you're going to take out the 3. You're going to take out the x squared. That will leave you with an x. When you divide 6 by 3, you're going to have a 2. You took out an x squared, so there's no x's left. On this side, we have a common factor of 5. Because there's a negative in the front here, you're going to pull that negative out with it, and you'll have an x plus 2 left when you divide by -5. Because if you divide 10 by -5, it should be plus 2. So you'll have an x left here and a plus 2, which is good because these two match. So that's going to be our common factor that we pull out in front, our GCF. And then you look at what's left. On this side, when I pull out x plus 2, I'm left with 3x squared. On this side, when I pull out x plus 2, I'm left with -5. And so then I am done factoring this one. There are times where you might be able to keep going, but we'll talk about situations like that in the future.